So for our next set of notes, these are parallel lines and the triangle angle sum theorem. You guys are probably familiar with this. Like if I asked you what do the interior angles of a triangle add up to be, most of you would say 180. So you're already on your way to understanding what it is we're going to hopefully understand by the end of these notes. So theorem 312 is the triangle angle sum theorem. You guys are going to use this a lot when you are doing your proofs and when you're solving problems. Basically it says anytime you have any kind of triangle, if you add up all the inside angles, in this picture over here we have angles A, B, and C. If you add up these angle measurements on the inside, you will always get 180. If you don't get 180, something's wrong, because in order to be a triangle, that has to happen. So this is going to be one of your basic expressions that you will substitute angle measurements in to allow you to solve for other angle measurements. So we're going to prove that theorem down below here. You do have to add one other piece of information, and that's going to be that these are parallel to each other. That's PC and line AB. So this line and this line have to be parallel to each other in order for us to do this. So add that to your proof. So PC, I know, I'm so sorry that that's so messy. AB. Alright, so now we have basically not a lot of information. All we have is that we have a triangle and we have two parallel lines. So from that you have to come up with information. Basically the only thing that we have going for us right now is we have three angles that add up to 180. So if you look at angle 1 plus angle 2 and 3, if you look at all those, you should see that they add up to be 180. So we're going to add that into our proof information, and then hopefully after that quiz you guys can start to see that you have a special angle pair here. You have two parallel lines, this line and this line, and alternate interior angles, A and 1, and then you have the same situation on the other side, 2 and B. Okay, so that is important information. Erase that. We're going to add that into our proof as well, and then hopefully that'll be enough information for us to solve and prove the triangle angle sum theorem. So let's start by doing our two-column proof. You guys can do it in the box in your notes. So we have our statements, and then reasons. The first statement, hopefully, you all know already, should be our given. So this is a triangle, ABC, and PC is parallel to AB. And that was given. Next, we have that supplementary, the 1, 3, and 2. These three form a straight line when you put them together. So I can add that to my proof. Measure of angle 1 plus measure angle 3 plus measure angle 2 equals 180. And all that is angle addition postulate. We've talked about that before. Angle, you can do AAP if you want, but I'll write it out so everyone knows what I'm talking about. But I'll put plus for addition postulate because I'm going to run out of room. Now, so far I have just this little piece of information, but my goal is to have A plus B plus 3 equal to 180. So far I have the 180. I have 3 in there, but instead of A, I have 1, and instead of B, I have 2. So that presents a problem. So we need to find a way to swap those two out. So we have to find some relationship to show that. And we talked about it already Angle 1 and A are congruent because they are alternate interior angles, and 2 and B are congruent because they're alternate interior angles. So I'm going to state that so I have something to swap 1 and 2 out with. So I'm going to say angle 1 is congruent to A, and I'm going to put it on one line. Angle 2 is congruent to B because they are alternate interior angles. So now I have some swappability. So these two are going to swap out, and these two are going to swap out. So I'll do that in red so you can see. Now I have measure of angle A plus measure of angle 3 plus measure of angle B equals 180 through substitution. And basically all we have to do is rearrange it so it looks just like this. And for the sake of saving my writing, I'm just going to draw an arrow like that and say I don't know, rearrange. You could skip this step entirely. I wouldn't mark you guys down for it. And I didn't even spell rearrange right. That's not good. Oh, I almost did it again. All right. So you guys can just forego this step and this step. Like, you can just make one of them. It would be fine. I wouldn't mark you down for that. You got to the brunt of it. Okay. I still think I spelled rearrange wrong, but moving on. Angle 1A, or example 1A, look, I'm totally on the angle. We're applying that triangle sum theorem. So we've already proved it, so we're free to use it. And the first question I need you guys to think about are how many triangles are in this picture, because students often miss this information. So think about it for a second. Hopefully you're thinking to yourself 3. You have this triangle, you have this triangle, and you have this whole triangle, okay? So keep that in mind when you're doing these problems, because you have to be able to make different equations. So if you miss one of those triangles, you could miss a key piece of information. So we are to find the values of x, y, and z. There's different ways you can start here. What I see first is I see this triangle right here has 2 out of the 3 angles. So if I said 39 plus 65 plus x equals 180, then I would be able to know that I need to subtract 39 and 65 from that 180. I'm trying to make that a little neater. So if you subtract that, you should get 76. 180 minus 39 minus 65. On your calculator, you should get 76. And again, I know I say this every time, you should be, before I do these problems, before you watch me do them, you guys should pause this and try and attempt them on your own. That way when you get stuck, when I do it, you will have that aha moment. You're not going to have that, and you're never going to know where you're going to be stuck until you get stuck. I know that sounds silly, but you really need to have the aha moment to make everything clearer. Moving on. So now I always say fill in your picture because it will help you in the end. That's 76. At this point, you guys could look at the overall triangle, or you could notice that these two, x and y, form a straight angle. So they add up to be 180. So you could subtract the one we just found, x, from 180 to get our y value. I don't know how many of you would have noticed that if you didn't try it, but that's often overlooked. So 180 minus x will give me y, and that is 104. And last but not least, you have two alternate ways now to do z. You can use the overall triangle, or you could just use this small triangle. Either way, you'll get the same answer. So if we use the small triangle, it would be 180 minus the top angle 21 minus the y angle we just found 104. And that's two of the three angles, so the third angle ends up being 55. So this z angle right here ends up being 55. Moving on. In this triangle ABC, angle ACB is a right angle, and segment CD is perpendicular. This means perpendicular creates 90 degrees with line AB. Find the values of A, B, and C. So again, you have three triangles here. So you're going to want to pick a starting point. We can pick a starting point in this triangle right here. Or we could, that's about the only starting point we got, I think. So to figure out what B is, I know this is 90 and I know this is 70, so that's two of the three angles. So 180 minus 70 minus 90 equals B, which ends up being 20 degrees. Oh, there was another starting point. I just seen it. This right here. This, you can barely see it, but it's a box right here. That's a 90-degree box. Since we have half of that angle, one side of it is 70, and we know the whole thing is 90, that only leaves C to be 20. So this 90 minus 70 equals C, which is 20 degrees. So now C and B are 20. So to get A, you can use this little triangle here, because this side is 90. We don't know what A is, but we just found C to be 20. So if we do 180 minus 90 minus 20, that's 60, or 70, sorry. So that's 70 degrees. So there's different places you can start here. It's just basically what your eye catches first. Now let's classify some triangles. When we classify, hopefully you guys are familiar with these. You're going to fill in your little boxes. The first one is equiangular. What that means is all your angles are the same. That's why you have those three congruent marks. This one, notice no angles are put off is the same, but that doesn't mean that no triangles, they could still have two of the same angles. So that ends up being just an acute. All angles are acute. That means they're all less than 90. All angles are less than 90 degrees. A right angle, you have one 90-degree angle, no more than that. And obtuse, the angles are greater than 90 degrees. Here the angle equals 90. Equilateral, so those four dealt with just angles. Now we're dealing with the side lengths. Equilateral means all the sides are congruent. That's why we have these little congruent marks here. An isosceles triangle, at least two sides are congruent. And scalene, notice there are no congruent marks. That means no sides are the same. So write all those out. You guys are, usually students are very familiar with those. And we are going to draw and mark a triangle to fit each description. If no triangle can be drawn, write not possible and explain why. All right, an acute scalene is basically this picture right here. So you could even just draw an arrow there if you want. That's an acute scalene. You can tell all these angles are less than 90 degrees, and with no congruent marks, you're showing that no sides are the same. And an isosceles right triangle would basically look like this with a right angle, and you have to mark 2 of the sides the same. So like that. In an obtuse equiangular, obtuse means you have one angle greater than 90, but equiangular means all the angles are the same. So if you have an obtuse equiangular, that means you have 3 angles that are all bigger than 90, and that isn't possible because the triangle angle sum theorem says when you add the 3 angles up, they equal 180. So if you have 3 angles bigger than 90, you're way above 180. So not possible. Okay. Remember, I'm going to keep going. You guys can pause and fill in. All right, classify this triangle by the sides and its angles. So when you look at this, you notice none of the sides are the same. So that should be screaming, you should be screaming to yourself, scalene. And by angles, you see this obtuse angle right here, so it's got to be obtuse scalene. So that's the classification by angles, by sides. All right, so now you have some definitions to fill in. Exterior angles of a polygon mean any angle formed by a side and an extension of an adjacent side. So down here you have this picture. Here's a side, and here's an extension of an adjacent side. Adjacent means next to. So that's an exterior angle. A remote interior angle is 2 non-adjacent interior angles to the exterior angle. So using the same picture, here's your exterior angle. It's the 2 interiors that are not touching that. They're across from. A silly way to remember it is when you're sitting on the couch, generally your TV's across from you and you use the remote on the TV. So if that helps you remember where the remote interior angles are, then good. If not, I'm sorry. It's the best I got. Now the triangle exterior angles theorem basically says that this exterior angle is equal to these 2 added together. That's what it says. So looking at the picture, angle 1 equals the sum of 2 plus 3. And that will help you out. That'll allow you to solve more equations and allow you to solve them simpler. Here's just a picture that demonstrates this theorem. If you took a triangle and extended and made the adjacent or the exterior angle and tore these corners off your paper triangle, you could put them side by side and they would fit perfectly right in that 1. So that's where they get angle 1 is equal to 3 plus 2. So let's do a couple examples and we will be out of here. Find each missing angle. So you have to think about what we just learned. You have an exterior angle that should, like bells should be going off. So I have this exterior angle and I have the 2 angles across from it. So that is that remote interior angles theorem. So all we have to do to get angle 1 is add up 40 and 30. And if you think about this, so you guys fully understand what's happening here, this saves you time because you could figure out what this angle is right here. Do 180 minus 40 minus 30. So if I do that, that's 140 minus 30, that's 110. So this angle right here equals 110. Its supplement, because these 2 add up 180, that means this equals 180 minus 110, which is 70. Okay, so you could do all of this work to get the same answer as just knowing this little formula. Okay, so B, same kind of process, but you got to subtract instead. You set it up. The exterior angle 113 equals the sum of the two remote interior angles, 70 and angle 2. So basically this time I have to subtract 70 from 113. And that gives me that extra remote interior angle. So measure of angle 2 is going to equal 113 minus 70, and I think that's 43. So there's that answer. Now, problem C says two angles of a triangle measure 45. Find the measure of an exterior angle at each vertex. So let's first draw a triangle. And it says this is 45 and this is 45, which makes this 90, because 180 minus 45 is 90. And they want to know what this angle is, this angle, and this angle. Well, hopefully you guys all see that that's 90. This obtuse angle is the supplement of 45, so we have to go, we can do 180 minus 45, or you can take this as the exterior angle and add 90 plus 45. So that ends up giving us 135, and these two are the same, so this must be 135 as well. Alright, and I think we have two more. What is measure of angle 1? Well, this is an exterior angle. These are the remote interior angles. So 125 should equal 90 plus measure of angle 1. So subtract 90 from 125, and you'll get what angle 1 is, which is 35. And last but not least, explain what's wrong with this diagram. Looking at it, this exterior angle is supposed to add up to its sum of the remote interior angles. So 80 should be equal to 85 plus angle B. Well, right here you should notice that's a problem, because there's no way 80 can equal 85 plus something, so that's the problem. So what you guys will have tomorrow, not today, unless you're going to be absent, you can jot this down or something. You'll have page 150 through, I think it goes through 151. It's 2 through 24, evens, 34, and 35. So you guys have the option. You could get this done now if you wanted, like if you're planning on going to the football game or something like that, or if you've got plans, but that's what you guys will have tomorrow to do in class. All right, have a good evening. Bye-bye.